Hi, welcome to Marker Board Videos. Today's video is on history of the atom. This is part one of a two-part video. So first thing I want to tell you is what we know currently. So right now, as of today, what we believe is that the atom is the basic unit of matter and that it consists of several parts. It consists of a nucleus with a positive charge inside the nucleus. The protons and the neutrons are in the nucleus, and it's surrounded by a cloud of electrically charged electrons. So you have a center core that's positively charged, surrounded by this cloud, if you will, of negative charges. That's our current belief. That's what we think the atom is like. So if you have atoms that have the same number of protons, which are plus, and electrons, which are the negatively charged particles, if they're exactly the same, that's called an electrically neutral atom. And that's a standard atom. That's when we say an atom, we're talking about electrically neutral. However, sometimes, and we'll get into this in a later video, but sometimes atoms want to either give or take electrons. And if they don't have the same number of positive and negative charges, if they have different number of protons and electrons, they're going to have a charge. It's no longer called an atom. Now it's called an ion. So an ion is simply an atom that has given or taken electrons. If an atom has a positive charge, it's given some electrons, and it's deficient in the number of electrons it has. If it has a negative charge, it's taken some electrons, so it has an excess. It has too many negatives, which makes sense. If it has too many negatives, it's going to have a negative charge. If it has too few negatives, it's going to have a positive charge. So let's talk about the history of how we got where we are. Let's start way back in the 322 area BC. with a guy named Aristotle. Now I know we've talked about Aristotle before, but basically what he said is matter is made up of 5 elements, which is interesting because mostly people talk about the first 4, fire, earth, air, and water, which you've heard before. Fire is hot and dry, earth is cold and dry, air is hot and wet, water is cold and wet. But then there's another one that he talked about, and it's aether, and aether is a divine substance that makes up heavenly bodies. So in other words, all the stars and planets are made up of this stuff called aether. They're not made up of fire, earth, air, or water. So that was Aristotle. Now things have changed a little bit since then, and not too long after 440 BC, Democritus actually that was before Aristotle, Democritus named the atom. He called it atomos. We now call it an atom. It's the smallest particle of matter, and it's tiny and indivisible. So if you're ever asked who gave atoms its name, it was Democritus. Now let's step way forward, a lot forward, to the 1800s when we had a guy named Dalton. And Dalton's model of the atom was that it was like a super ball. It was a solid, hard sphere. And that's what he believed an atom was, a solid, hard sphere. And for many years, we agreed with him that it was a solid, hard sphere. But what's more important was we came up with this atomic theory, and I know there's a lot of words written on here. So let's distill it down as easy as possible. There are 5 parts of the atomic theory. The first part says that all matter is made up of atoms. The second part says that if you have atoms of a specific element, they're all identical. So an atom of hydrogen is an atom of hydrogen is an atom of hydrogen. It has the same size, the same mass, and the same properties. An atom of gold is an atom of gold is an atom of gold. Same size, same mass, same properties. If it's different elements, they have different properties. So if you have gold and hydrogen, they're going to have different properties. So far, that's pretty intuitive, I think, but here's where he kind of makes a jump. He said that compounds, which we've been studying, are simply a combination of 2 or more different atoms, and they combine in a simple whole number ratio. So you have 2 or more different atoms, they combine, and it's a simple whole number ratio. So like you have H2O, we don't have H1.630, 7.29. It's simple whole number ratios, 2 hydrogens, 1 oxygen. And when you have compounds, that's what you'll find, simple whole number ratios. Also, number 5 in his atomic theory says that atoms can't be subdivided, can't be created, cannot be destroyed. They can be rearranged, and that's how they form compounds. And they can be rearranged again and again and again, and all that does is form different compounds, different compounds, different compounds. So there's the 5 points of Dalton's atomic theory. Late 1800s, early 1900s, we had J.J. Thomson, and he came up with, at the time, we called it the plum pudding model because plum pudding was something people were familiar with. I know now when we say plum pudding, that doesn't mean a lot to you, so I'm going to give you another way of remembering that in just a minute. But the Plum pudding model, through the Plum pudding model, he discovered electrons. And he said that electrons were negatively charged plums in a pudding of positive matter. He also said that the negative charge is balanced out by the positive charge so that the atom is neutral. And there are spaces in between atoms, which is something we hadn't really talked too much about before. So let me give you an example. I call it the gum in the sand model, because if you have some chewed gum and you're at the beach and you cough or laugh or whatever and you spit it out and it goes in the sand and you pick it up, those sand particles are embedded in that gum. You can't pick those sand particles out very easily. They're embedded in it. And so it would be like negatively charged sand particles in a sea of positively charged bubble gum. So hopefully that gives you a better view of J.J. Thomson and the Plum pudding model.